Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. So tadi saya dah buka dah link untuk kehadiran. So sekejap lagi boleh pergi dekat link kehadiran yang sama yang kita pakai untuk minggu ni. So boleh klik link kehadiran lah dekat situ. Okay, sekejap buka. Okay. Right, so basically today we are going to start with a new chapter, chapter 3, which is sequences and series. So altogether, I'll spend around 3 hours for this chapter, of course. And then once we finish with chapter 3, we are going to proceed with chapter 4, matrices and system of linear equations. So kita buat chapter 3 dulu, nanti kita masuk chapter 4. If I'm not mistaken, by next week we should be able to finish chapter 3. And then the other week we are going to start with chapter 4. Okay, so let us start with chapter 3. Oh, before that, is everyone okay? Boleh dengar clear? Ada masalah apa-apa tak? Ada apa-apa masalah? Screen ke apa ke ada apa-apa masalah? Kalau tak ada, saya nak teruskan. Clear? Okay, good. Right, so now let us start then sequences and series. So there are a few learning outcomes today. We are going to learn two things. The first one, you have to learn how to write the n term of a simple sequences and series. So the n term means that we want to write down the n term. Term stand for t term. And then you should be able to determine the n term, which is the n, of an arithmetic sequence where the formula is the n equal to a plus n minus 1d. So this is the formula for the n term of an arithmetic sequence. And to use the sum formula, so for sum formula, we have two formula. The first one is n over 2 to a plus n minus 1d. So this is the first formula. And then this is the second formula, n over 2 a plus L. Okay, so what are the differences between them? N same, A is the same, but over here we got L. What is L? L is the last term. So A is the first term, right? So for this formula, you are going to take the first term, you plus with the last term, and then you times them by n, divide them by 2. Okay, so that is the formula. Tapi tak apalah, nanti kita proceed banyak sikit example. Okay, next. Let us go to the first learning outcome, which is to write the n term of simple sequences and series. Okay, so what is the difference between sequence and series? Okay, sequence. For example, 1, 3, 5, 7 and so on. So this is a set of number arranged in an order. Okay, so you're gonna start with the first term. So this is the first term, second term, third term, fourth term, and so on. So one thing that you should keep in mind is that the n is a natural number. So this n over here, they should start with one natural number, kena start dengan satu lah. So that is why we are having something with the first term, second term, third term, fourth term. So dia tak ada zero term ke, negative one term ke, tak ada. Okay, so now series. Series is the sum of the term of sequence. So this is T1 plus with T2 plus with T3 plus with T4, so on. So this is series. Okay, so again, what are the difference between sequence and series? Kalau sequence, we use comma. If it is a series, we are going to use addition because it is a sum. So kalau nampak plus minus, then those are mostly series. If we simply have comma, then those are sequence. Okay, so example 1a, find the first 5 term of the sequence defined by the following general term. So we have Tn equal to 2n square minus 1. Okay, so they want us to find the first five term. The first five term meaning that you have to know what is T1, T2, T3, T4 as well as T5. Okay, so how do we get T1, T2, T3, T4 and T5? Okay, so look at over here. This is Tn equal to 2n square minus 1. In order to get T1, you simply need to substitute with n equal to 1. In order to get T2, substitute n with 2, substitute n with 3, substitute n with 4, substitute n with 5. So that one will become the first term, second term, third term, fourth term and fifth term. Okay, so substitute 1, so 2 times 1 minus with 1, so it will become 1. And then T2, substitute n with 2, so 2 times with 2 square minus 1, so 8 minus 1, so that is equal to 7. And then T3, 2 times 3 square minus 1, so we got 3 square, 9, 9 times 2 is 18, 18 minus 1, so this is 17. T4, so we should substitute n with 4, so 2 times with 4 square minus with 1, so 4 square is 16, 16 times 2 is 32 minus 1, so 31. And then T5, 2, 5 square minus 1, which will give us 49. Therefore, the first five terms are 1, 7, 17, 31, 49. So we simply substitute the value of n and then we simplify the number a little bit. What is the number? Okay, so that is basically how we solve number 1a. Okay, let us try to do 1b now. Okay, again, find the first five terms. So we are going to find out what is T1, T2, T3, T4, as well as T5. So Tn is n over n plus 1. So now we should substitute the value of n with 1, 2, 3, 4, and 5. Okay, so substitute n with 1. So T1 is 1 over 1 plus 1, which is 1 over 2. And then T2 is 2 over 2 plus 1. So this is actually 2 over 3. So simply substitute the n. And then T3, so 3 over 3 plus 1, which is 3 over 4. And then T4 is 4 over 4 plus 1. So this is 4 over 5. And then T5, you simply substitute n with 5. So 5 over 5 plus 1, so 5 over 6. So that means the first five terms are 1 over 2, oops, 1 over 2, 2 over 3, 3 over 4, 4 over 5, and 5 over 6. Okay, so done with the first example, let us proceed with the second example. Okay, so second example is actually the first learning outcome where you have to find the n term of a simple sequence and series. Okay, so find the n term of a sequence whose the first several terms are given. So the n term, so term stand for t. So t, so this is the n term, that means we are looking for tn. So tn for this sequence. So we got 4, 7, 10, 13, 16. Okay, so we do see some pattern over there, right? So 4, 7, 10, 13, 16. So the difference is always equal to 3. So what can I do is that I can actually compare with a multiple of 3. So multiple of 3, for example, 3, 6, 9, 12, 15. So I can actually compare them with a multiple of 3. So this is 3n. Okay, so how do we get 4, 7, 10, 13, 16? Okay, so from 3 to 4, what should we do in order to change 3 to 4? 6 to 7, 9 to 10, 12 to 13, 15 to 16. What should we do? So the answer is you have to add 1. Okay, so just now we have a multiple of 3, which is 3n, and then you need to add 1 to them in order to get 4, 7, 10, 13, and 16. Therefore, the n is 3n plus 1, starting from n equal to 1 up until 5, because we have 5 term over here. So T1, T2, T3, T4, T5. So that is the reason why you have n equal to 1 up until 5. So Tn equal to 3n plus 1, starting from n equal to 1 up until 5. Okay, so done with that. Let us proceed with 2b. Okay, so again, find the n term. We are looking for Tn. So we got 1 over 2, 3 over 4, 5 over 6, 7 over 8, and so on, dot, dot, dot. It means it's going infinitely. Okay, so now let us think about our numerator first. What do you see in your numerator? And what do you see in your denominator? Okay, so in my numerator, I see 1, 3, 5, 7. So the pattern that I can see is that we keep on adding 2. So that means I can easily compare them with the multiple of 2. So similar thing happen with the denominator. It's 2, 4, 6, and 8. So this is actually a multiple of 2. Okay, so let us compare this with the multiple of 2. So 2 over 2, 4 over 4, 6 over 6, 8 over 8. And then as you can see, for this denominator, they are already equal with this one. Now, the only thing that is different is the numerator. But what happened to the numerator? How can 2 become 1? How can 4 become 3? How can 6 become 5? How can 8 become 7? Do you guys know how? We tak tanya tu. Do you guys know how? How can 2 become 1? 4 becomes 3? 6 become 5? 8 becomes 7? So the answer is we have to deduct 1 or minus 1, deduct 1 or minus 1, whatever, subtract 1. Okay, therefore, for your numerator, you have to deduct 1 to them, but for our denominator, we can directly use 2n. Therefore, the n is 2n minus 1 over 2n, starting from n equal to 1 up until infinity. Okay, so the reason why we are having this infinity over here is because you have the plus dot dot dot. The plus dot 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 means that this sequence going infinitely. So that is why you should write down infinity. Kalau dia berhenti je sampai 7 over 8, we're gonna write down 4. Because this is first term, second term, third term, and fourth term. So kalau dia berhenti sampai situ, sampai 4 je lah. But it keeps on going, therefore we should write down infinity. So this is a simple sequence. Okay, next. The partial sum of a sequence or series. For the sequence T1, T2, T3 up until Tn and so on, the partial sum are, so S1 is called the first partial sum. So S1 is actually equal to T1. So that means the first term. S2, so this is the second partial sum. So that means you should do T1 plus with T2. Okay, so if let's say we have S3, so this is sum of the first 3 terms. So S3 will be T1 plus T2 plus T3. S4, it will become T1 plus T2 plus T3 plus T4. So those are S4. Okay, so S1, the first partial sum. S2, the second partial sum. S3, that is the third partial sum. If we have Sn, then Sn is T1 plus T2 plus T3 up until Tn, because this is Sn. Okay, so now if you don't have your notes, you should write down these two formula. What is Sn? Sn is T1 plus T2 plus T3 up until Tn. And then how are we going to calculate Tn? Tn is Sn minus Sn minus 1. Okay, so if let's say I give you S2, right? S2 is T2 plus T1. What is S1? S1 is equal to T1. If I want to calculate T2, then I simply do S2 minus with S1. Why S2 minus S1? S2 is T2 plus T1. So if I deduct with T1, I'm going to get T2. So that is basically how we get this formula. But of course, this is a simple example. But this is the general formula, Tn equal to Sn minus Sn minus 1. So that means if you want to get the fifth term, this is S5 minus S4. If let's say you want to get T14. T14 is equal to S14 minus S13. Okay, so done with that. Let us proceed to the next one. Okay, so T1 plus T2 plus T3 up until T5, this is a finite series. So finite because we don't have the plus dot dot dot. If we have the plus dot dot dot, this is infinite. That means it's going to infinity. So kalau finite tu maksudnya dia berhenti. Kalau infinite, it means that it's going to infinity. Infinite ke infinite ke suka hatilah panggil je lah apa-apa pun. Kita kelas maths bukan kelas bahasa Inggeris. Panggil je lah. Infinite pun boleh. Layan kerja. Okay, next. Right, so given that Sn is 2n squared plus 3n, find the sum of the first 5 term and the next 5 term. Okay, so we got Sn equal to 2n squared plus with 3n. Okay, sum of the first 5 term. First 5 term, that means we are looking for S5. The next 5 term, that means after S5, so T6, T7, T8, T9, T10. So this is the next 5 term. Okay, so firstly, we need to calculate first what is S5. So how do we get S5? So you already have the formula for Sn equal to 2n squared plus 3n. So we are going to substitute n with 5. So we got 2, 5 squared plus with 3 times 5. So 25, 2, 50, 50, 65 then. Okay, so that is S5. So how do we get sum of the next 5 term? Okay, so if let's say I wrote down T1 up until T5, where is S5? So S5 is the sum starting from the first sum up until the starting from the first term up until the 5th term. And then where is the next 5 term? So that is T6 up until T10. Okay, the formula that I have is only involving S. Therefore, I should try to use S. So T1 up until T10, they are actually S of 10. T1 up until T10 is the sum of the first 10 term. And then I already calculate the value for S5. Then I can easily calculate the sum of the next 5 term. Okay, so how to do that? We basically need to calculate the sum of the first 10 terms and then we minus with the sum of the first 5 term. Then you can get the sum of the next 5 term. Okay, so the sum of the next 5 term, so that is S10 minus with S5. Okay, so how do we get S of 10? So you should substitute the value of n with 10. Alamak, salah copy. Okay, so 2 times with 10 square and then plus with 3 multiply with 10 minus with 65. So you should substitute n with 10 and then minus with S5. So the final answer for this one is 165. Kalau tak cantik nanti kan saya tulis balik. Saya tak tulis. Okay, tukar dah. Right, June. Next. Okay, so that is for A, sum of the first 5 term and sum of the next 5 term. So now B, we should calculate what is the fifth term. Okay, so with sequences and series, you should be extra careful. Fifth term. So this is D5. So dia kena keyword sum, term, yang tu kena take note sikit lah. Sum ke term. Okay, so find the fifth term. So that means we are looking for T5. Okay, so we only have the formula for Sn. So I don't have the formula for T. So if you want me to calculate what is T5, that can be quite hard. So why don't we use the formula for Sn? Okay, so the formula that I told you to use is Sn minus Sn minus 1. Okay, so I want to get T5. So let us substitute n with 5. So T5 is actually S5 minus S5 minus 1. And then of course, this one you should simplify them. It will be S of 4. So T5 is S5 minus S4. Okay, so S5 we already calculated earlier where we get the value is 65. S4 you should substitute the value of n with 4. So 65 minus 2 times with 4 square plus with 3 times 4. So simplify them a little bit. So T5 is actually equal to 21. Okay, done. Next. Okay, so arithmetic sequence. Arithmetic sequence is actually sequence of the form. So this is A plus D, A plus 2D, A plus 3D, and so on. Where A, what is A? A is the first term, and then D is a common difference. And then how do we get the n term? So the formula is Dn equal to A plus n minus 1. So this is the n term. Okay, next. Right, so example 4, find the n term for the arithmetic sequence 9, 4, -1, -6, -11. Okay, so the first thing that you should take note is that this is arithmetic sequence. So write down arithmetic sequence just for us to remember that this is arithmetic. So all the formula that we are going to use must involve arithmetic. Okay, so arithmetic has two things. The first one is the first term. The second one is the common difference. So for arithmetic sequence, there are two things that you should find out. What is the first term? And then what is the common difference? Okay, so I'm sure by now you should be able to see that the first term is actually 9. So that is our first term, D1 over here. So the first term is 9. How are we going to get the common difference? So basically common difference, you should take the second term and then you minus with the first term. Since they already told us this is arithmetic sequence, that means the common difference will be the same. So normally I will take the second one minus with the first one. So 4 minus with 9. So the common difference is -5. Okay, so I already have the first term, I already have the common difference. Now we need to find the n term. So the n term stand for T, n term, so this is Tn. So the formula that we are going to use is Tn equal to A plus n minus 1 D. Okay, so what is the value of n? The value of A, the value of A is 9. What is the value of D? The common difference. That is -5. And then N will stay as N. Sebab dia memang minta N term. Dia tak bagi nilai N tu berapa. So kita kena bagi secara general. Okay, so Tn is equal to A plus N minus 1D. So substitute the value in. And then of course behind here you should expand them a little bit. So this is n times with -5, -1 times with -5. So you are going to get 9 minus 5n and then plus with 5. Simplify them a little bit because we have some numbers over here, over here. So 9 you plus with 5, so it will become 14. So 14 minus 5n. So that is actually your Tn. So that is how we are going to find the n term of the arithmetic sequence. Okay, next. The 11th term of an arithmetic sequence is 52 and the 19th term is 92. Find the 1000th term. Okay, so 11th term, that means this is T11. An arithmetic sequence, so just write down AS to remind ourselves this is arithmetic sequence, is 52. So that means T11 is equal to 52. Is equal lah. Is to symbol equal. And the 19th term, so 19th term, this is T19, is equal to 92. So they give us T11, 52, T19, 92. Find the 1000 term. So we are looking for T1000 equal to what? Okay, so let us solve the simultaneous equation first because we need to find out what is the first term as well as the common difference because we don't have the first term and the common difference yet. So for arithmetic sequence, you should calculate what is the first term and what is the common difference. So itu dua benda yang penting lah untuk arithmetic. Okay, so what do we know about Tn? Tn is A plus n minus 1d. So just now I have T11, so I can substitute. T11 is A plus with 10D and that is actually equal to 52. So this is my first equation. And then T19, that is A plus with 18D and this is equal to 92. And that is the second equation. And then of course we should try to solve them simultaneously. I do find that using elimination method is much more easier. So I'm going to take the second equation minus with the first equation. So second minus with 1, A minus A, 18 minus 10. So we got 8D equal to 40. So D will be equal to 5. And then substitute into either the first or the second equation to calculate the value of A. So I choose the first equation. So from the first, A plus with 10 multiply with 5 must be equal to 52. So 10 times 5 is 50. So A times 50 is equal to 52. That means that A must be equal to 2. So now this is arithmetic sequence. I already find out what is the value of D, what is the value of A. Now we can easily calculate what is T1000. Okay, so Tn is A plus n minus 1d. So that means T1000 is 2, which is the A plus 1000 minus 1, which is 999, and then times with the common difference. So T of 1000 is 4997. Okay, so done with this, let us proceed with the sum because we already quite good with the term. So sum. Okay, so sum of the first n term. Okay, so just in case you don't have your note, you should write down these two formula. Sum of the first n term. So the first formula is n over 2, 2a plus n minus 1d. So that is the first formula. The second formula is Sn equal to n over 2a plus n. Okay, so again, I repeat, what are the differences between these two? Okay, so they are using the same first term and they are using the same common difference. But the difference over here is that this is actually the first term plus with the last term. Lagi sekali lah saya repeat, just in case ada yang tak sempat salin lagi kan. So A is the first term. So if let's say you have a sequence, and you know what is the first term for that sequence, and you know what is the value for the last term of that sequence, then you can easily use the second formula. Okay, next. Find the sum of the first 50 odd numbers. Okay, so sum of the first 50. So this is S of 50. So what is the value for S50? Okay, so the first 50 odd number. So firstly, we need to list down first. What is the 50 odd numbers? So of course, I'm sure you know what is the first odd number. The first odd number is 1. So we got 1, 3, 5, 7, and so on up until T50. Okay, so if you want to, you can do 1, 3, 7, 9, 11, and so on up until T50. But I guess I might do a lot of mistake if I do something like that. That is the reason why I'm using T50 over here. So now I want to calculate what is the value for T50. So I want to know what is my last term. Okay, so for this one, this is an arithmetic sequence because I do see a common difference between them. So the common difference is 2 and my first term is 1. So the first term is 1, the common difference is 2. So what is T50? So we are going to substitute into the formula. So Tn is A plus n minus 1D. So I'm going to calculate what is T50. So T50 is 2 times with 50 and then minus with 1. So T50 is equal to 99. So now I know my first term and I know my last term. Okay, so now you can choose which formula do you want to use, either the first formula or the second formula. But for this series, I already know what is my first term and my last term. So I'm going to use the second formula, which is n over 2 and then a plus l. Okay, so n, what is n? N is the number of terms. So now this is the first 50 term. That means the value of n should be 50. So n will be 50. The value for the first term should be 1. The value of the last term will be 99. So we already calculated them earlier. So this is S of 50, 50 over 2, 1 plus 99. So you simplify them a little bit. You are going to get the value is 2500. So that is the sum of the first 50 odd term. Okay, next. I think we are at the last example already. Okay, so example 7. How many terms of the arithmetic sequence 5, 7, 9, and so on must be added in order to get 572? Okay, so how many terms arithmetic sequence? This one must be added. So must be added, that means we are looking for sum. So sum of what? How many terms is this? In order to get 572. So we want to calculate what is the value of n. Okay, so now we do know that the first term is 5. I'm sure you can see, right? The first term is 5 because we start from 5. And then the common difference, so is simply 7 minus 5, which is 2. So the common difference is 2. And then from the question, they told us that Sn must be equal to 572. Okay, so the only way in order to get the n is by using Sn. Sebab yang ni je pun yang ada n, yang lain tak ada n kan. So we are going to use this information. Okay, so Sn, what is the formula for Sn? Sn is n over 2, 2a plus n minus 1d, and this is basically equal to 572. Okay, so what is the value of n? I didn't know what is the value of n. In fact, that's the thing that I want to find out. So we're gonna leave n as n. So tinggallah n tu sebagai n. And then what is the value of a? A is actually equal to 5. What is n over here? Again, I didn't know what the value, so I'm just gonna keep them as n. And then d is actually equal to 2. So I now know the value of a, I know the value of d. So let me substitute the value of a and d. So it will become 2 times 5 plus n minus 1 times 2. Okay, so what happened next is that I will expand each of them. So I will have n over 2 multiply with 2 times 5. So n over 2 times with 2 times with 5. So we are going to cancel out the 2 and 2. So this is n times 5, which is 5n. And then n over 2 multiply with n minus 1 multiply with 2. So you're going to cancel out the 2 and 2. And then we are left with n multiply with n minus 1. Okay, so 5n plus n minus 1 equal to 572. So now it does looks like something. So this seems like a simple quadratic, right? The only thing that we need to do is just expand the bracket and then perhaps bring 572 to the left. Okay, so let me expand and simplify them first. So it become n squared plus with 4n minus 572 equal to 0. Okay, so now you can use your calculator and find out the value of n. Okay, so by using your calculator, you should be able to get n minus 22, n plus 26 equal to 0, which means that n is equal to 22, n is equal to negative 26. Okay, so now this is my question to you. So please answer this. Are we going to choose both or are we going to choose one? Kalau both, kenapa both? Kalau one, kenapa one? Can you give me some reason? I'll give you around 2 minutes for you to type. Are we going to accept both answer? Why? Are we going to accept only one answer? Why? Kalau one je bagi, yang mana satu? 22 or negative 26? Oh, Hakim dah jawab dah. Sebab dia tak boleh negatif. Okay, tak apa. Kita tengok orang lain pula. 22. Are you sure, Faiza? Why? Choose the positive number. N equal to 22. Kalimah kata choose the positive number. N equal to 22. Ada lagi yang tengah type. Lagi nangis sebab saya tak baca. Mana-mana ada lagi. N should be natural number. Wow. Nur Faizah, nombor dia semakin meningkat. Okay. Satu sebab N satu lagi negatif. Kena ambil nilai positif sahaja. Okay, so basically the one that positive number because D equal to 2, not negative 2. Okay, so now the reasoning skill lah kan, dalam banyak-banyak tu kan, reason yang saya paling suka adalah reason yang apa nama dia, Koei Chun Kiat. Tak tahu lah betul ke tak, kalau salah maaf sebut nama. N should be natural number. N should be natural number sebab tadi kita dah define kan, kita ada T1, T2, T3 and so on, where the value of N should be natural number. I told you before that you should start from 1. Yang ni yang paling sedap lah kita dengar kalau natural number. Tapi betul juga orang cakap N tak boleh negatif tu, betul. Betul je. Okay, so now we can only choose N equal to 22 because N need to be greater than 0 and N need to be a natural number. Oh, saya ingat tak ada orang nak sebut natural number, lepas tu saya tulis greater than 0. Okay, tak apa lah. Alright, so I think that's it. done with this one. So we are done with the first lecture on chapter 3. So I'll see you guys later. So jumpa sekejap lagi lah untuk tutorial. So tutorial sekejap lagi kita bincang yang absolute value tu kita habiskan yang exercise tu. Okay, so jumpa sekejap lagi. Bye-bye. Lupa nak cakap, asal budak-budak tak suka like video aku lah.